You ask your company's AI assistant a simple question. What's our overarching policy shift on the data privacy across all our 2024 contracts? And it gives you one paragraph from one document. It has no idea the other 9 contracts even exist. That is not a bug. It's literally how standard RAG works. It grabs the single closest matching paragraph and answers from that alone. Today, I'm building something different. A system that doesn't just search text, builds a knowledge graph and actually understands how your documents connect. It's called GraphRAG. I built the whole thing for $0 on a laptop with no GPU. Now we might think, okay, but I'm using an advanced setup, re-ranking, hybrid search, maybe query decomposition. Doesn't that fix it? Not really. Advanced RAG is still fundamentally chunk based. It retrieves the top few text snippets most similar to your question. If the real answer is scattered across 10 contracts and a policy doc, no single chunk contains it, so the model guesses and hands you half the picture and calls it done. Here's the exact scenario I built for this video. 2 client contracts and 1 internal data privacy policy. Both contracts reference that same policy. One contract promises a 72-hour breach notification. The other negotiated a stricter 48-hour window. Ask what's our overarching data privacy shift across our 2024 contracts? And the answer literally doesn't live in any single paragraph. It only exists in the connections between 3 documents. GraphRag flips the approach. Every chunk gets sent to an LLM with one instruction. Tell me what entities are in here and how they relate. Not freeform. I gave it strict schema. Policies, contracts, parties, clauses, obligations, relationships like governs, amends, references, supersedes. That constraints is what keeps the graph clean instead of turning into a mess of duplicate, inconsistent labels. Here's the actual result. The data privacy policy sits in the middle and both contracts connect straight to it and to each other through shared clauses. This is the structure standard RAG simply cannot see. Here's the actual build. Runs on a completely standard laptop, no GPU. LlamaIndex orchestrates everything. Neo 4J Community Edition free runs locally in Docker as the graph database, and a local embedding model, BGE small, happily runs on CPU. The one step that needs real horsepower is entity extraction, so I offloaded that to Groq's free API, a 70 billion parameter model, completely free, that my laptop could never run on its own. Once ingestion finishes, I open Neo4j's browser and literally see the graph it built. Every entity is a node, every relationship is a labeled edge. I can visually trace a clause in the Bluefin contract all the way back to the master policy document. And here's the fun part. A simple browser interface, no terminal needed. I type what's our overarching policy shift on the data privacy across our 2024 contracts. Watch. It pulls from the policy and both contracts and gives me the real difference. 2022 policy had a 5-day window. 2024 tightened it to 72 hours. And Bluefin negotiated on even stricter 48-hour clause. 3 documents synthesized into one answer. Let's actually prove this matters. I ran the exact same 3 documents on the exact same question through 2 systems. On the left, a genuinely advanced RAG pipeline, chunking, embedding, and a re-ranker pulling the top 5 most relevant passages. On the right, the GraphRAG system we just built. Watch what comes back. Advanced RAG's answer leans almost entirely on the policy document. The single most semantically similar chunk to the question it mentions there was a policy shift in 2024 in general terms, but it completely misses that Bluefin negotiated a stricter 48-hour clause instead of the standard 72-hour. Because the fact lives in the different document and no chunk connects it back to the policy shift wording in the question. GraphRAG's answer, same question. It names the actual shift from a 5 business day window down to 72 hours, cites both contracts by name and specifically flags that Bluefin negotiated a stricter 48-hour clause. That's the difference graph traversal makes. It's not retrieving the closest text, it's walking the actual relationships between entities to assemble the complete picture. Under the hood, this isn't magic. Every chunk gets sent to the LLM with a strict instruction. Only extract entities and relationships from this fixed list. That constraint is the single biggest lever for graph quality. Without it, the same real world entity ends up with 5 slightly different names and your graph turns into a mess instead of a map. Vector search alone finds you the single closest point. Graph traversal starts from that point and walks outward through every connection before the answer even gets written. That's the entire trick. So how does business take this from a 3 document weekend build to something running on thousands of contracts? 4 upgrades. First, swap local Neo 4j for Neo 4j Aura, the managed cloud version. Same graph model, zero server maintenance, built-in backups, and it scales past what Docker container on the laptop ever. Second, swap the free Groq tier for dedicated higher throughput inference, either a paid Groq tier or a self-hosted GPU deployment if data residency rules mean nothing can leave your infrastructure. Third, add an entity resolution layer merging data privacy policy and the DPP into one node. Essential ones, you are processing hundreds of documents, not. Fourth, wrap the whole ingestion pipeline in a real orchestration tool, Airflow or Prefect. So new documents get processed automatically on a schedule with retrieves and monitoring, and put real authentication in front of the web interface before anyone outside your laptop touches it. So that's GraphRAG, a knowledge graph built from your documents that can answer the questions standard RAG simply cannot see. And I built the entire working prototype for $0 using free tools and a free API tier on laptop with no GPU. I have put the entire project code, setup guide, sample documents, link in the description so you can build this for yourself this week. If this helped, subscribe for more real working AI builds like this one. Thanks for watching.